Hello, this is part 2 of the multimedia set of slides that we are using in this class. It's a side dish, it's a set aside. I'm not going to teach part 2 in week 2. Week 2 starts immediately with part 3, which is Excel, much more important. But sometimes during the class we will refer to what is in the slides. So it's a good thing if you take your 10-20 minutes to watch the slides, to have a look at what is this, and perhaps we are better off then when we will refer to the content of this set of tools and also computer architecture stuff. Somehow you need to know how a computer works, and you need to know that there are a few tools that are handy, like zip, unzip, and image processing, something you have met already. This is just for a comprehensive set of teaching material available for all of you. So let's move on. It is somewhat necessary for you to have a basic understanding of how computer architecture is. What is an operating system? What is an application software? This is the set of slides that explains you all this. Amazing as it may seem to you now, all computers are created equal. Allow me to express myself somewhat emphatically. Since the beginning, since the 40s, when a computer was the picture that you see on the lower left so first thing first, even if you might find it difficult to understand or to believe it, all computers are created equal, if you allow me to use somewhat an emphasis in this sentence. The bottom left corner shows you a 1940 IBM first electronic computer. In the middle you find a modern iMac, and then also some other example car computers. On the left side, the blue picture is one of the Google server farms. Each one of those box there, it's a rack as tall as a man, containing some 50 or 60 computers inside, in slide computers. And well, all computers work with the same basic architecture. To let you understand what I mean by the same basic architecture, I show you here a Fiat 500, my first car actually. And it still works. It was born in the 60s, I guess, in the late 60s, early 70s. And then below you have a Ferrari. So this is Italy, so this is Italian cars. It's the smallest and the best cars available in this country, probably over all the world actually. And well, they still have, each of them, 4 wheels, a steering wheel, seats, light, an engine, an electric system, brakes. The architecture around which these two so different cars are built, we may say it's the same. And the way to drive it, well, you know, with a lot more care with the Ferrari, but you drive it with the same driver's license. Once you've learned how to use one car, you can use all cars. This is not so good, so right for computers, but nevertheless, I'm trying to explain to you that there is a basic architecture that works for everything. One architecture for cars, another architecture for computers. Next slide, we look at that. The basic architecture around which all computers are built is the von Neumann architecture. You might want to have a look at that link, von Neumann, on the Wikipedia, but it's basically, we have a memory which is separated by a processing system, a CPU, a central processing unit, which is separated by input and by output. I mean, trivial, not at all, believe me. This is one of the first results that led the word to the IT revolution. At the core of a computer, it's a central processing unit. If it's a computer, it has a central processing unit. If there's a central processing unit, a CPU, then it's a computer. Around the computer, we have a primary storage, normally the hard disk, normally the RAM memory, a secondary storage, which is usually the hard disk, communication devices, keyboard to input data, printers and video to output the data, and a system to have all these components communicate, which is normally on something called the motherboard of a PC or of a computer, and it's called the bus. Another way to look at how a computer is built and how it works is to think to all the physical stuff, silicon, plastic, metal, as the hardware. And then there is a software system that talks to the hardware, the system software, which is specific for that kind of hardware. And then there is an application software, an outer layer, that talks with the system software. That's not nice. One more way to understand how computer works is to think about a layer system, or in this case, an onion organization. The center is, of course, the hardware, the physical thing you tap your fingers on and watch on the screen. The hardware alone doesn't work. If there is no system software, the hardware is just there silent. The system software is the first important piece of software that it's specific to that kind of hardware. Windows, Linux, Mac OS, those are examples of system software. We also call them operating system. On each operating system, on Windows, on Linux, on Mac, then you may find application software apps, things that actually are used by the user that do not access directly the hardware, but only works with the software that performs the operations he or she wants to actually carry on the machine. So Word, Excel, PowerPoint are examples of application software. A more classic representation is actually layers. Below we have the hardware. The operating system works with the hardware and also interfaces with the application. The application interfaces with the operating system and then finally with the user. So we have 4 different levels of environments to deal with. Among the tools you will happen to use very frequently, you will find the compress, decompress, or zip and zip tool, the screenshot tool, and of course some image processing software like Photoshop. Commonly used every day, necessary to understand. One by one, we will briefly cover all this. When you take a screenshot, or when you just select and copy some text, this stuff goes into a buffer temporary memory called the clipboard. When you paste something on your Word, for instance, or in your Excel, anywhere, that pasted stuff was stored in this very same memory called the clipboard. As a standard, you can only store one copy thing. If you copy something else, the first thing you copy, it's overwritten, and you paste only the last thing that you copy. It's a software facility for short-term storage that disappears when you switch off the machine. You may find clipboard managers applications in Mac. It's common, that allows you to copy one item, copy a second item, copy a third item, and then when you paste your S, if you want to paste 1, 2, or 3. But as a standard on Windows, you have only one shot on the keyboard, on the clipboard. a few words are necessary to describe compressing archives. It's common when you download your personal stuff from, say, Facebook or from Google, that Google or Facebook creates a zip file. It's a compressed archive that contains many other files. Sometimes you download a zip file, which is only just one file, zipped to speed the transmission, because a compressed archive stands to reason it's smaller than a normal standard archive. A problem is Windows shows you zipped file, compressed archives, as if they are normal files. Well, they are not. If you work inside a zipped thing, then you probably cannot save it. This is a trick we will have to meet sometimes during the class. So you take a normal folder. At Jankabot we have a tool called 7zip, which is a zipping archive, and you create this mynewbook.zip. So following with that example, once we zip the archive, we had the original mynewbook folder and then a mynewbook.zip, which is a zip compressor folder. The zip compressor folder contains all the files that were in mynewbook, a copy of the file. mynewbook is not destroyed, it's just copy and compressed. And indeed, if you double-click the zipped folder, you will find the original folder inside. Actually, it is not a normal folder, it is a compressed folder. That means you cannot use it as it is. Think about your sweater when it's in the closet. It's stored there, you know it's there, but you cannot wear it. You have to take it out of the drawer, out of the closet, unfold it, and then you can wear it. Same thing with this compressed archives. They are just compressed as a way to use less space on your hard disk, or less bytes in the transmission if they are to be sent over the mail, for instance. So if by any chance you start to work on some file that it is inside a zipped folder without taking it out of the zipped folder, Windows creates a temporary copy of that file where you work on. But then when you close it, it's deleted. You cannot save it. You might save it as, but you cannot save it as it is. So you better not work inside the zipped folder. And then how do you work? You take that folder inside the zipped folder and just drag and drop it out of that zipped folder. And when you drop it out, it's automatically decompressed, and so that works. Of course, this makes sense only if you're moving that file from somewhere else, from somewhere to somewhere else. To do this thing on the same machine, it's just a silly exercise. So let's say you have now taken the zipped folder on a new machine, bringing it with a USB pen drive or whatever. And on the new machine, you have the mynewbook zipped folder, which inside the mynewbook folder. Just dragging out of the zipped window that folder will decompress it, and then you may have again mynewbook with all your chapters decompressed and ready to be worked with safely. If this doesn't make sense, don't worry, it will happen in class and we will discover them together later. I'm pretty sure you already know how to work with images. But since this is a start from scratch class, I need to quote the fact that the technique is that you find the image, you right-click and save that image as on your computer, if that's allowed. Normally it is, unless you are in some sort of image show environment. And then you can modify using a graphics editing software, changing that picture, resize, crop, modify colors, things you probably already know. There are many graphics editing software. Adobe Photoshop is the most common used graphics editing software. I think we have Adobe installed on our computers, but that requires a little bit of learning to use it. I choose to use PhotoFilter, which is installed on our computers at the Garibaldi Lab, which is very, very easy image processing software to use, and it does all that we really need to do normally dealing with Office documents. So PhotoFilter, it's the one we will use, but if you know how to use Adobe Photoshop or Creative Suite, you're welcome to use that already. Just a very simple recap on the different kind of image formats available for the pictures. First warning is BMP is the one to avoid. It's a bitmap and it's a pixel by pixel copy. It's the default format Windows uses, unfortunately, but it takes a lot of memory and we much better use different file formats. Later, next slide. One of the most common image file formats is the GIF. GIF, if you click on the links on the picture, you can explore all the details of this kind of format. Suffice to say now that it is 256 different colors and supports animation and also transparent background. Animation and transparent background are two good things that GIF has, but 256 different colors is not enough for our eyes to see the image as being in true color. So this is mostly used for logos, for geometric pictures, or graphics, artistic things. JPG stands for Joint Photographics Expert Group. It's another compression algorithm. It's another format that allows us to use millions of colors. And we call these images as true color images. That's a very famous National Geographic picture of a girl in Afghanistan 20 years ago. It's a bit larger in size than GIF, but now storage is no more of a problem. And so probably JPEG, it's the format I recommend as a default standard to use anytime. One more file format you might meet is PNG. It's a professional format. If you have to send something to a professional printer or to a publishing firm, they will want PNG. PNG has many advanced features. You can work on different layers together of the image. Like in this case, you can modify the fox, you can modify the rings, you can modify the world, and then act on each part of the image as if they were a different image overlaying. That's it for PNG. If we need it, we can just use it as any other format, but now you know that PNG is the professional standard. Courtesy of one of the web design books, this is a simple comparison of the three different formats. And last, this is the links to the photo filter tutorials. We will often use the software in class. And this is all for the tools and system architecture of this course. If something is not clear, you are anyway welcome to ask me clarifications in class by email or via the forum on Moodle. Now let's move on to Excel, which is more important.